Hello everyone and welcome back to another WSI Access tutorial. My name is David and I'm going to take you through a talk about normalization. Now that sounds like a pretty scary term for some of you, but don't worry, we're going to we're going to explain everything in as non-technical a way as we can. But what I really want to get at and show you in this demonstration is what is normalization, but also the larger concept of spreadsheets versus relational databases. Now, you may have heard of the topic of relational databases. Furthermore, you may have looked at your Office installation, your Office 365 installation, and you know what the blue W is, you know what the green X is, probably know what the red P is. But that A stands for access. That is a relational database system. What the heck is a relational database system, and what the heck is normalization? Well, and what does this mean for your business? What does this, I'm a business owner, I run a store, or I run a paving company. What does this mean for me? Okay, well, we're gonna get into all of that in this video. So I want to talk first about what is data. Well, everything's data. Your employee records, customer records, sales records, inventory, accounting, bookkeeping, address books, contact lists, sales leads. If you're an educational program, students, classes, enrollment, everything that you do for your business is data, no matter what. And so, most likely, you're using one of several things to keep track of your data. Maybe it seems simple enough that you can keep track of it on an Excel spreadsheet or even by pen and paper charts. That's great, but we need to understand what data is and what normalization is and what advantage does a relational database such as Access give you that even a sophisticated spreadsheet program like Excel cannot. But first I want to talk about bad data. This is, what you see in front of you is a recreation of a recreation of data from a client app, an actual client app that I worked on a couple of years ago. And when we looked at the data, we saw something like this. Again, this is a representation, but you see this is just completely, messed up, for lack of a better word, right? I mean, you got states spelled several different ways, some of them wrong, some have dots, some don't, some have the zip codes right in with the state. Some have spelled out, some of the zip code where states should be. I don't know what near is. I don't know what post office that is. A zip code's in the city. I mean, you can see this is just not a good situation. And most likely, this resulted from a database or application where data entry was free format, where you could just basically enter anything you want. The state is a text box, the zip code is a text box. And that's just asking for a disaster, because what's happening is you might have the exact same place name, but it's spelt 5 different ways. Some have spaces, some have don't, some have dashes, some don't. And really, it makes it a real mess when you want to search for that place. You want to search for that information. So let's take a look at what a typical spreadsheet table in a sales situation may look like. So we look at this and we see order date, full name, address, city, state, zip. Now, I realize this spreadsheet is not all inclusive. I mean, you would have the first name and last name in separate columns, and you'd probably have a shipping cost. Okay, so I mean, just to save space, I left out some columns. Tried to simplify this a little bit. But what I'd like you to do, as a little bit of a challenge, pause the video for a moment. Do you see any problems with the organization, the structure of the data? Again, there's some missing columns. Full name should probably be separated out. There should probably be a second address line. That's not what I'm talking about. Do you see any structural issues with the way this data is set up? And we'll just pause for a moment and give you a chance to look at it. Okay, ready now? All right, let's see how we did here. Now these are only I gave you some answers here. This is probably not all inclusive. I mean, if we look, we could find a lot of problems here. Let's start with the full name. Not only with name and address, you have a lot of repeating information. So you have the same order. Look at these first two rows: the same order date, the same name, the same address, same city, same state, same zip. Of course, they're different product names because there's two products in this order. Shipment method probably is specific to a particular order. I guess in most cases. Your results may vary. But it looks like the only things that would generally differ here are product name, cost, and quantity. Everything else repeats. And that is a recipe for disaster. Because, let's just give you a few examples here. Let's figure Cindy and Charles Brown, let's say they're married because we notice they have the same address. Okay. Now, suppose Cindy still had her maiden name in here and she had to change it to Brown. Well, you'd have to change, let's say it was Smith, right? You'd have to change it from Smith to Brown in every instance. Suppose you had a table, you're a medium to large size business, you've got a table with 10,000 orders in it. Cindy Brown might appear several hundred times. You're going to find every single one of them and change them to Brown? And what's worse, let's suppose the Browns move to a different address. You have to know they're married. First of all, you have to know that both of their addresses have to be changed on top of finding all their addresses, assuming they're spelt the same way in every case, and you have to make sure you change all of them. And that's assuming that this was not a free entry. Then maybe one of the entries here has two A's in it, an Nevada Avenue or Nevada Road. How the heck are you going to manage that? That's a lot of trouble. Suppose the cost of a PC goes up. Now, this is not product data. This is order data. It's likely that you probably are going to store the cost in two different places. You're going to have a cost in the products table, and that is going to go up with time or up or down as the price changes. But probably the cost that's in the orders table is going to stay the same because you want to have it reflect the cost at the time the order was placed, not necessarily the current cost. But nevertheless, this is the only place it exists. So you probably want to have a separate list of products so you can keep track of the current price and yet still have the original price in the orders table. So you do need to store both. And so I'm not going to go on too much further. Maybe you found other things, and there probably are other things, but this just gives you a general idea. This is a no-no. But this is about what you're going to get in Excel. And you could get kind of a relational type situation with Excel, but not very easily. So let's look at a process called normalization. It's what we call, and it's a technical term we use in database parlance. Basically what it means is we kind of segment out the tables, or kind of using math terminology, we kind of factor out certain columns. I mentioned that probably if we go back to the previous slide, the only things that probably change from order to order is the date, order number. Probably line to line, you're only talking about the product cost and quantity. This is the only thing that changes from from order line to order line. So what we've done is we've taken, and this is only the first step. I mean, there's different types of normalization. I'm not going to get technical here, but I color-coded these things for a reason. So the purple, what's outlined in purple, actually, let's start with the red. What's outlined in red are things that are not going to change from order to order, and they're not going to change from order line to order line. Remember, so one customer places several orders, and every order has order lines. So we want to be able to relate the customers to the orders. We want to be able to relate the orders to the order lines, and that's why we call it a relational database. This is what Excel can't give you, at least not without a lot of very unnecessary work. And so basically what we see here is we've factored out, we've taken the customer table, we've taken the order information, and for lack of a better word, we factored it out into a separate table. And so what you see here is the customer information in the order is now represented by a customer ID. We've added this. We didn't have a customer ID before. Now we do. So now every customer appears only once. So if a name changes, you change it just here. If the Browns move, you change it just here. Now that doesn't get you around the fact that the address is still in there twice. You know, we could get more sophisticated by making an account and having the address, have them both in the same account, and the address related to the account and not the customer. So we could really go in finer and finer details with this. But the idea here is that this is basically, in a nutshell, is what normalization is. We're saying that Cindy Brown and all her information applies to both of these orders. And so we're simply going to take her customer ID, where we're going to simply represent all of her customer information with a single value, a single column. This 2, which will map back to this 2, relationally map back to this 2, and that's where we have all of the other information, the address and all the other things. So the customer ID in red here, this is what we sometimes call a primary key. A primary key is a column or columns that uniquely identifies a row. In other words, customer ID, because there's no repeats. So we could, you don't want to make the name your primary key, even if you separated between first and last name, even if you made, first name and last name the primary key. Well, there could be more than one Charles Brown. That's not really reliable. So that's what we choose. Now, the customer ID over here in purple is what we call a foreign key, because that relates. This can have multiples, but it will all relate back to this one single row. And that's the process in a nutshell that we call normalization. It's basically splitting up the tables to avoid repetitive data. In a nutshell, that's what we're talking about. Now, we could go further with this. We could take the orders table. Even this isn't perfect, because even in the orders table, okay, these are the same order. I'm going to assume these are the same order because they have the same order date. May not be, but let's just assume that for now. Again, there's still some repeated information, such as the date, probably the ship method. If there is a ship date, that's probably going to be in common as well. Shipping cost, tax, total, you get the idea. So we do a second split here, and we take, we do a second split, and we take all the common information to an order, and we really shouldn't even have the full name in here. Again, this would be this would have been replaced. Full name and related information would have had the customer ID. So this would probably be a Cindy Brown was 2. Yeah, so this should probably be a customer ID that says 2. But I wanted to keep it somewhat readable, so I left full name in there. So now you have a common order, and that order represents, now the order number is a primary key in here, and the order number here is a foreign key because we have common information, order date and customer, that we can factor out. And now, so ultimately what we want is, other than things like order number, we want as little repetition between rows as possible. I'm not going to get completely all of it. And probably, now that I'm looking, we could probably, ship method could probably be in this table too. So there's, it depends. Sometimes, like when you order on Amazon, right? Sometimes different items are shipped separately. So that's, that's going to depend on your business model. Most cases, I'd probably put ship method in with the orders, but that's okay. What you're seeing here is a screenshot taken from within Microsoft Access. I've added some annotations here to just kind of illustrate, but we see that customer ID is a primary key for the customers. The customer ID from orders relates back to it. Order ID is the primary key for the orders table. I don't think we put an order ID in this. Yeah, we didn't put an order ID in this table, but we did here. So order ID, the primary key here, I'm sorry, no, wait, so we got the order ID is the primary key in orders table. Now, in the order lines table, I mentioned a primary key is column or columns. Now, again, you could do this several ways. Basically, we want to, in this case, I chose we can reuse order lines. You don't want to have, if order 1 has lines 1 and 2 and 3, there's no reason why order 2 has to start at 4. Order 2 can have a line 1, a line 2. So for that difference, so because order lines can repeat, we can't just use order line by itself. So we use the combination of order ID and order line, and the order ID still relates back to the orders table. And we even did something further with the products table. Because, and again, this is a little bit different because we may very well want to store the cost in here because these are historical, if the product price changes, then we still want to store the original price. But that means we still need a place to store the current, so this would be the current price, whatever it is at that time. And this would be, you could put product cost in here as well, so you can show what the cost was when that order was placed. But again, there's no need to include all information about the product in order lines. For example, product name. Well, why do we need, we can say it's a smartphone, it costs $400. Smartphone, again, you look right in here, we have repeated information, right? So we separate the products out too. And so it's this cascading level, and which means if the name of a product changes, you change it only over here. If a price changes, you change it only over here. If the quantity, you really wouldn't change an order quantity after the fact, but you would change it here. If there was a mistake in the order date, you need to enter it. You only change it in one place. There's less redundancy. There's less repeating. It's far more organized than having to hunt through those Excel spreadsheets. Having free text entry. Things are spelt different ways. You got to find all the records and change them. That's a major headache. And I've seen a lot of projects where I look at the data and I'm like, oh my God, this is just, so, you want to keep things organized. You want to keep things, so that's how, that is, in a nutshell, is what normalization is. It's the separation out of repeating data. I mentioned relationships. So let's take, again, this is also a screenshot from Access, and I'm not really going to go into the technical details here. Basically, what this screen is saying is that the customer ID in customers matches up must match up to a customer ID in orders. And we have this thing called referential integrity. And what that means is, if I try to enter an order, and let's suppose this is all our customers. If I try to enter an order for customer 1700 and there is no customer 1700, well, that's going to produce a pretty big problem, because now you're entering an order for a non-existent customer. There's no one to bill for it. I mean, you could just imagine all the problems that can cause. All right, so basically what this says, when you say enforced, it says that if you change the, if you enter a customer in the orders table, it better exist in the customers table or Access will return an error. Now, the cascades here are happen. Well, what if a customer ID is updated? What if a customer is deleted completely? What happens? Now, the way this is set up is that if a customer ID somehow changes, so let's say 1508. So Ryan's customer ID changes to 9999. Then all 1508s in this table will automatically change to 9999. It's cascading down to the lower table. And the cascade delete says that if we delete Ryan John, then all of the orders related to him will also delete. And of course, that could also cascade down to the order lines. Again, sometimes you'll want to cascade the update, but not the cascade delete. So, but you'll get an error message like this if you try to violate that relationship. And what you can see here is you can see in Access we could even have tables nested within other tables. I mean, they're not literally nested, but you look at the relationship, it shows you we have the orders within the customers, then we have the order line within the orders. So this is what data relations does. It allows you to tie these things together. And so, just to kind of recap the advantages, you have less repetition of data, you can edit and delete, we don't have orphaned records, you don't delete a customer, and then have all of their orders still in there that don't have a customer to relate it to. Uses less storage because of less repetition, reduces data entry errors. If you enter a customer, if you enter an order, you can make sure that customer does in fact exist. You're not making a mistake, entering the wrong name, entering the wrong ID, and that type of thing. So data is everywhere. Hopefully you've seen the costs of not having organized and normalized data, and we've seen some, if not all, of the solutions that we can use to avoid these issues. Thank you for watching. We hope this video was all the help you needed for your Access database. If you are struggling to create an Access database that does what you need it to do and just want someone to make that happen for you, that is the business we are in. Our contact information is below the video. You can reach out to us and we will work with you to determine how long it will take and how much it will cost to get your database up and going. If the time and cost are acceptable to you, WSI will get to work and make your database vision a reality. Perhaps Microsoft.NET or MS SQL Server would be the better choices for your new database, so it can run on your Windows desktop or anywhere in a web browser. WSI will help you make this determination if you like. Again, thanks for watching. Please remember to like and subscribe, and have a great day.